What you're looking at right now wasn't made in Blender, Unreal, or Unity. It's running in a game engine that I built from scratch. Hi, I'm Selby, and you're about to watch me slowly lose my sanity while I try to make my own game engine with OpenGL. Welcome to my OpenGL journey. Why, you may be wondering, why would I make my own game engine when there are already so many popular ones out there? Engines like Unity and Unreal already do the hard stuff, rendering, lighting, basically the magic. Most game developers learn programming to make their game, but that's not for me. I'll make a game to learn better programming, which means I can finally write code so cursed it works once and I'll never understand it ever again. And honestly, I have no game idea, which is usually considered an important part of game development. So I decided, until divine intervention hits me with that dream project, I'll just build the engine first. If you have watched any OpenGL videos before, you probably know that it all starts with the triangle. So I did what any normal person would do. I went to YouTube and I found an OpenGL tutorial. Created the project in C, linked the libraries, made a window, and finally, the triangle. I was super excited, even though I didn't understand anything, like at all. Not the shaders, not the buffers, not the pipeline. I was basically just copying ancient spells off the internet and hoping the GPU gods were pleased. But hey, it worked, which means I was now officially a graphics programmer. And then, like any other responsible developer, I spent the next 400 hours playing War Thunder and completely forgot the project existed. Okay, I realized something. I never actually explained what OpenGL actually is. So very quickly, OpenGL is basically an API that lets us talk to the GPU to draw things on the screen, like triangles, cubes, circles, and existential regret. Now OpenGL isn't the only option. There is also something called Vulkan. It's like OpenGL's cooler cousin that goes to the gym. It's usually faster, but way more complex. From what I've read online, most people recommend learning OpenGL first before moving to Vulkan. So that's exactly what I'll be doing. Anyways, back to the story. Later, the stars aligned and I was hit with unprecedented motivation. For the first time in human history, I sat down and read the tutorial from Learn OpenGL. I know, learning by reading. Absolutely insane behavior. So I opened up CLine and created a new project and gave it a very reasonable name. Which I think really shows my confidence in long-term planning. But there was one small problem. We still need to actually connect OpenGL to the project to use it. This is usually done with a tool called CMake. Now in my previous attempts, I just copy pasted a CMake file that someone else had written. Did I understand it? No. Did it work? Yes. Which means it was perfect. This time, for some unknown reason, instead of doing the smart thing again and focusing on learning OpenGL, I decided to learn CMake from scratch. Which was a mistake. So I clicked build and waited for CMake to do its magic. And then the screen got filled with red text, warnings, and even threats. At one point, I'm pretty sure it insulted my ancestry. So naturally, I did what any experienced developer would do. I panicked and then watched a 35-minute tutorial on CMake. And surprisingly, it worked. I finally understood how to link OpenGL along with libraries like glfw and glad properly. Which meant, for the first time, I wasn't just copying ancient spells off the internet anymore. I actually knew what I was doing. Well, mostly. And now, I could finally start learning OpenGL for real. Then I logged in and made the triangle again. But these triangles have the emotional depth of cardboard. I mean, yeah, technically impressive, but visually, we were one step away from Microsoft Paint. But at this point, I was thinking, if we can draw shapes, we should be able to slap an image on top of them and make it look impressive. How hard could that possibly be? Turns out, textures are where things started getting interesting. Because the GPU doesn't just magically know how to stick an image onto a shape. You have to tell it everything. Which part of the image belongs to which part of the triangle, what to do if the texture is too small, whether to repeat it, mirror it, clamp it, and even which resolution to use when it's far away. Yeah, there's a lot. But before any of that, we need to actually load an image into the program, which we can do using a library called stbimage. It basically turns a PNG file into raw pixel data that we can send to the GPU. And thanks to the emotional trauma I endured learning CMake earlier, adding the library to the project was actually painless, which felt illegal. So we load the texture with STB and Once the image is in memory, we ask the GPU to reserve space for a texture inside its VRAM. Then we configure how it behaves. Do we want sharp pixels, which is great for pixel art, or smooth interpolation, better for realistic stuff? Then we decide how the texture warps when coordinates go out of the image. And finally, we generate something called min-maps, which are basically smaller versions of the same texture, because if an object goes far away, there's no point in sampling every single pixel it has. So the GPU just switches to a lower resolution version automatically. It's both faster and looks better. And after all that, we send the texture to the shader, cross our fingers and hope nothing explodes. And finally, it worked. And this is the moment things started to feel real, because I wasn't just drawing shapes anymore. I could control how surfaces looked, which meant it was time to go bigger. Okay, earlier I casually said we send the texture to the shader, that's a normal sentence. But what even is a shader? A shader is basically a tiny program that runs directly on your GPU. Not the CPU, the GPU, which means it's fast, like stupid fast. And here's the wild part. Shaders are literally what decide where every single pixel on your screen goes. Every color, every shadow, every glow. Your Minecraft shaders, your Valorant skins, everything on your monitor, shaders. But the crazy thing is, we get to write them. And if you write something simple, you get something simple. If you write something interesting, you get this. And if you're absolutely cracked at maths, you get whatever this is, and also this, and this too. This is from a site called ShareToys. It runs on WebGL, which is basically OpenGL inside your browser. It looks insane, like genuinely illegal levels of cool, because it's a live render and not a recorded video. I actually recommend opening it in another tab right now. Just don't forget to come back, please. Now here's the thing. At this point we have a triangle, textures, and custom code on the GPU. Technically this is already a 2D game engine, which means I could stop here, make a 2D platformer and call it a day. But no, because drawing a 2D triangle is easy. Turning a 2D triangle into a 3D world, that's when things start getting dangerous. Right now, our triangle is flat. Emotionally flat, physically flat, spiritually flat. It exists in 2 dimensions. Which is fine if you're a triangle, but I want depth, I want perspective, I want to move the camera, not feel like I'm inside Microsoft Paint. So the next problem becomes, how do we trick the GPU into thinking something exists in 3D space when our screen is completely flat? And that's where matrices enter the chat. By the way, if you're enjoying the video so far, leave the video a like. And if you want more stuff like this with Kasane Teto in it, subscribe. This is my first YouTube video and took a long time to edit, so seeing feedback would help out a lot. Alright, enough self-promotion. Let's ruin everything by adding another dimension. Right now, this triangle is 2D. There's no depth, there's no perspective, and it is spiritually flat. If I move it further away, nothing changes. It's not how reality works. Okay, now the problem is, OpenGL doesn't understand 3D. It only understands numbers between -1 and 1. Anything outside that? Gone, deleted, clipped out of existence. So if we want depth, we need to transform our vertices into something OpenGL accepts. And apparently, that requires 5 different coordinate systems. I just wanted a cube. Why do I need to learn 4-dimensional math? For all the matrices and maths related stuff, we can use a library called GLM, which I can easily link to the engine because I'm a CMake expert now. First one, local space. Every object starts in local space. Your cube thinks it's the center of the universe and it spawns at 0, 0, 0. Main character syndrome, yeah. But the world does not revolve around your cube. So we introduce the mole matrix. This is the put it somewhere else matrix. It rotates, scales, and translates. Basically tells your cube you're not special. Now the cube exists in a world, other objects exist too. They all share the same global origin. Now that everything's in place, view space. Now we need a camera to look around, but here's the problem. You don't move the camera, you move the entire universe around it. Yeah, when you move in Minecraft or Valorant, you're not moving forward, but the world is moving backwards. I know, feels crazy once you know it. Next, projection. We just basically slap GLM perspective onto a matrix, and suddenly objects farther away look smaller, like how it works in real life. But Selfie, how does it actually work? I don't know. After all that, every vertex goes through this formula. Right to left, because maths wants to confuse us. And then, just like that, we went from flat Kasane Teto PNG to a slightly 3D-ish looking object. But there's a small problem. Right now we are basically a floating spectator in the void who can't move. Can render 3D stuff, apply textures to them, and even have shaders doing their best. But it's not much of a 3D world if we can't move around and enjoy it in its full glory. And in a game engine, that's kind of a problem. So, we need a camera. Now OpenGL doesn't actually have a built-in camera system, which means we have to make one ourselves before I accidentally open up Instagram and start doom scrolling. Like I mentioned earlier, when you move forward in a game, the camera itself doesn't actually move. And this solution is created using something called the view matrix. Luckily, GLM gives us a helper function for this called look at. All we need is the camera position, the direction it's facing, and which way is up. Then we connect some keyboard input, the classic WSD for movement, and after a little bit of struggle, we hook up the mouse movement, which lets us rotate the camera using yaw and pitch, which finally lets us fly around the scene. And just like that, we went from a static, slightly 3D looking object to a real 3D world. And honestly, I was way too excited when I reached this point. But like I mentioned earlier, I didn't actually have a game idea, and at this point in my journey, it suddenly hit me. Instead of making a single game, why not make a game engine? So I immediately got to work. But every game engine needs one thing first, a name. Something that doesn't sound like Unity, Unreal, Godot, STL or Pygame. So I thought about what I actually wanted this engine to be. Poly meaning many possibilities or like any kind of game idea, and Blast meaning speed, power and things happening fast. Put them together and you get Polyblast. Yeah, I even designed a logo for it. And this was actually the first time designing anything in Figma. Up until now, I always thought front-end stuff wasn't for me. UI, design, CSS. I assume people just sat there writing CSS like psychopaths. But apparently, normal people just use tools like Figma and actually design things visually, which made things way easier. Now, the name logo was done. But game engines also need something else, an icon logo, like the ones Unreal, Unity and Godot have. But obviously, it had to be original. So I asked myself, what does OpenGL love the most? Triangles. And what's the first letter of our game engine? P. So with a very big upside down P and a bunch of triangles, you got this. And honestly, this turned out way better than I expected. I genuinely thought I was about to create something that looked like a 3-year-old's drawing in Microsoft Paint. But this was pretty decent. And putting that logo on the GitHub page suddenly made everything feel about 10 times more professional. Which is insane, because before learning OpenGL and C++, I was basically 100% backend. Design was never something I expected to enjoy. Now we have a solid foundation. But let's be honest, this wasn't really a game engine yet. Right now, it's basically just a camera and some cubes, which is not exactly Unreal Engine level. A real engine usually goes one of two ways. Either it's a library or framework style engine like a Steel or Raylib, which are honestly really fun libraries to use, or just a GUI editor like Unity, Unreal or Godot. And technically I could build something like that using a library like ImGUI, but for this OpenGL version of Polyblast, I'm keeping things simple, a library or framework style engine, because the real goal here isn't just OpenGL. I'm learning OpenGL as a stepping stone to Vulkan, and once I understand all the graphics fundamentals, I want to rebuild the engine properly using Vulkan. So this OpenGL version of Polyblast is basically phase 1, the training arc, and if everything goes well, Polyblast V will be where things start getting seriously interesting. So if you want to see where this project goes next, subscribe to follow the journey. I'll also be posting shorts showing my progress through the Learn OpenGL course, because this is already the biggest project I have ever built. To be fair, my previous projects weren't anything impressive, and surprisingly, I haven't abandoned it after 2 days like my previous projects, which is honestly a new personal record.